Hello all. Today I'll be talking about the Bernoulli's equation, which is a concept of a fluid dynamics, which generally relates the pressure, the velocity, and height of a moving fluid. All right. So before going for the physical significance and the equation of the Bernoulli's, I would like to draw your attention towards some real life applications. All right. So suppose if I ask you a few questions, just try to think about it and try to answer that. Suppose there is a fast moving train. So why does the fast moving train pulls off all the nearby objects? All right. Or if I ask you why does the cricket ball swing, you must have noticed this thing. Or if I ask you what is the basic principle of generation of the lift by which the plane flies, or if there is some heavy winds, some cyclones, some typhoons, the roofs are blown away. All right. So these are some applications which definitely are going to be related to the Bernoulli's equation. So let's see what is Bernoulli's equation. So the Bernoulli's equation is basically a form of the conservation of energy which tells us that energy can neither be created nor destroyed. All right, it can only change its form. So if you consider that conservation of energy principle, that means the sum of all the forms of energy in a fluid will be same at all the points. And definitely, when we are talking about the Bernoulli's equation, there is a assumption that we are talking about some incompressible fluid and inviscid fluid. All right. So if you're not aware about the incompressible fluid or inviscid fluid, just try to look for it. Or if you want me to explain in some new videos, I would definitely be making some videos. If you want it, let me know. So that means if you have the kinetic energy, the potential energy, and the internal energy, if you make a sum of it, then the sum of all these energies will remain same at every point inside a fluid. All right. So if you say that, that means if you increase the speed of the fluid, that will be accounting for a decrease in pressure, static pressure I'm talking about. All right. That means eventually we are talking about that decrease in fluid's potential energy. So if you want to see about the equation which Bernoulli's follow, it is mentioned in the bottom right corner. All right. So if you see this diagram, which is basically a converging and diverging duct, there are two sections. One is the entrance section, which we have named as section one, which is having a more area, and the second section is having a less area, which is kind of a venturi. All right. So if you go for a mass conservation tells us that the place where the area is more, the velocity will be less, all right, because the same amount of fluid has to pass through a bigger region, it can pass very slow. But the place where the area is less, the velocity will be more because the same amount of fluid has to pass through a small area, so it has to be fast, all right. So more area means low velocity. Low velocity means high pressure. High pressure. How this comes? Because of Bernoulli. The section 2, where the area is less, the velocity will be more, the pressure will be less. So, what I want to tell about the Bernoulli is how I have understood it. If you have a fluid, if you're aware that the fluid is incompressible and the inviscid fluid, you simply have to think one thing. If the velocity is more, the pressure will be less. If the velocity is less, the pressure will be more. All right. So let's go back to the slide number one, which where I have asked few questions to you, and we'll discuss about this Bernoulli's principle. All right. So the first case, why this fast moving train pulls up the nearby objects? Now, it's very basic. If you understood what I explained in the last slide, if the train is moving fast, that means the air near the train is moving fast. That means it is having the high velocity. If it is having the high velocity, it is having low pressure. And outside the far region, the pressure is atmospheric pressure, all right? So there is a potential difference created, pressure difference created. I'm so sorry, pressure difference created, and the air tries to suck all the things because there's a positive pressure gradient. So all the objects are sucked towards the train. Okay, that is the reason why this fast moving train is trying to pull all the nearby objects. Now coming to number two, why does the cricket ball swing? Although I'm going to explain it very vaguely, it's not a complete detailed explanation. I just want to give you an overview how it happens. So you must have seen players rubbing one side of the ball, alright? So rubbing one side of the ball makes its surface very smooth. Okay, the flow of the air is laminar kind of thing. You can assume it's laminar. whether the rough side will be having a rough flow that you can say turbulent flow. All right. So this rough side will be having some kind of turbulent flow giving high velocities, and this smooth side will be having less velocities. So high velocities means low pressure, low velocities on the right side means high pressure. So there is a pressure which is there is a pressure difference created from right side to the left side, and the ball swings towards left. All right. This is the second thing. Third thing, how does the airplane takes off? Although there are a lot of discussions about generation of lift by our wings, and this is not exact definition, exact reason. The Bernoulli's is not exact reason, but just to give you overview, what they say is basically the air moves faster on the top of the airfoil because of the shape, and the air moves slower in the bottom. Okay, so the slower air is having high pressure, the faster air is having a low pressure, giving eventually a positive upwards force that we call a lift, and that's how the plane flies. The fourth thing, why does the roof are blown away in that event? So suppose you have air moving faster on the top, all right, because top there is no restriction. Top side means near where the clouds are around 100 meters, 50 meters on that side. Okay, so air is moving faster there, and near in the bottom side where your home is, the basically air is moving slower. So on top, the air is moving faster, the pressure is low. On the bottom, air is moving slower, pressure is high. So there is a net pressure gradient from bottom to top. Hence, the rooms are blown away. Okay. So I hope these are some examples, some real life examples I could think of to tell you how Bernoulli's are applied. So Bernoulli's is simply in two lines. If you have to say if there is a fluid, definitely you have to be very particular about the assumptions what we have made, which is an incompressible fluid and inviscid fluid. All right. If you have that you have satisfied these conditions, then you can apply the Bernoulli. You can simply say the pressure uh, wherever the pressure is high, the velocity will be low. Wherever the velocity is high, the pressure will be low. All right. It's the same thing, I think. Yeah. So I hope you get the idea.